Hi, my name is Lisa Richter. I'm the Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is CSIA's mission is to help system integrators build better businesses. How do we do that? Well, for starters, we have a team of volunteer system integrators who have crowdsourced a best practices manual to help system integrators scale their businesses. In fact, the BP manual has just released a beta version of the latest manual 6.1. CSA also offers a certification program and other resources, including professional development, learning from peers, and access to vetted professional services companies, including insurance, legal, and financial, who understand an SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For system integrators and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources, from accounting to sales to operations, 365 days per year. It also means you and your team can attend the CSIA conference, because this annual in-person event is members only. If you are currently a CSIA member, thank you. We are doing some renewals, so if you haven't renewed your membership, please do so. If you want to get just a flavor of CSIA and its members, you can listen to the Talking Industrial Automation podcast. CSIA members talk about all things industrial automation, and it's just a great way to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have any questions, which we welcome during the presentation, please use the Q&A feature in Zoom. That helps us stay organized. The session is being recorded, and you will get a link to the recording in the next day or so. At this time, I would like to turn it over to today's speakers, Ben and Nathan. Take it away, guys.
All right, thanks, Lisa. Good morning, everyone. We're going to start with some quick introductions, and then we'll get into some of the topics that we want to discuss with everyone. So thank you for joining. My name is Ben Lyons. I am the Senior Business Development Manager for Life Science and Specialty Chemicals at Avid Solutions. We are a CSIA certified system integrator headquartered in Winston-Salem, North Carolina. A little bit about me, my background. I currently live in Raleigh, North Carolina. My education is in biochemistry, cellular, and molecular biology, and through that path, I kind of fell backwards into automation. I think as so many people do. Previously, I was the manager of bioprocess engineering at North Carolina State University's Biomanufacturing Training and Education Center, where I had hands-on experience in Delta V systems, ABB 800XA, PASX, MES system, Labware LIMS, and a whole host of other IT and OT integrations. So that really kind of helped build the foundation to coming to Avid Solutions. If you've seen my name around, it's possibly because I'm making connections with as many people as possible. I also act as the IT Media Committee Chair for the ISPE Carolina South Atlantic chapter. So that's just a little bit about me. Let me turn it over to my friend Nathan, and we'll get started.
Ben, I appreciate you joining me today, and all on the call. I appreciate you making time for this. My name is Nathan Henderson. I'm a next generation automation specialist at Schneider Electric. Previously, I did come from a system integration background. Spent about 6 years doing that with an industrial engineering background in the past. My role, is essentially that of an evangelist. It's to get the message out, to introduce customers to emerging technologies, to organizations and standards that are not generally publicized in mainstream ways. And Schneider is a very hands-on, person-to-person conversation partnership mentality as to how they deploy things.
Awesome. And so do we want to just quickly introduce Osama?
Yeah. Osama, if you want to jump on, he's here to support me. He's the technical arm of my role, but Osama, go ahead.
Yes, hello guys. Osama Helmi, and I'm with Schneider Electric as well as a SAE solution architect. Where this platform that we're gonna dive into is one of my favorite platforms that I like to talk about. And I'm just excited to be geeked out with this group here. I also come from the biomedical background that jumped into the automation world, and I was working with a systems integrator for, about 7 years or so. So I got to taste all the flavors of the different automation platforms. So excited to be here. Thanks.
Awesome. Thanks, Osama. Nathan, you mentioned a next generation automation specialist in your title. That's not your standard business development role title that I have. What do you mean by that?
Next generation is not something I put out there lightly. I truly am of the opinion that the automation world is really going through a paradigm shift, a significant evolution in technology in the way that we've done things traditionally for the past 60 years versus where we're going to be going in the future, that really simplifies the engineering effort, that reduces the complexity, that adds cybersecurity and robustness, that unifies different manufacturers and vendors. Next generation really challenges the status quo as to what we have been doing for, I'd say, the past 60 years.
So what exactly is changing? I mean, that's a lot right there. That's a lot to unpack.
The key buzzword that I know we're going to revisit often during this presentation is software-defined automation. That's really the paradigm shift and the game changer. It's taking the control layer, the software itself, and decoupling it from the underlying hardware, making the automation platform itself focus more on the software and less dependence upon the hardware. So we can introduce portability between your application and not have it vendor locked to a specific system, so that we can introduce vastly superior computational power to the control layer, whereas PLCs are typically very deterministic and purpose driven with little ability to execute high computational tasks.
Yeah, I think that's that's going to be a lot of the mentality that we need to just kind of unlock a little bit as we have this discussion, is what's the difference between traditional hardware driven technology and software defined automation. So like from a system integrator perspective, we're thinking, our standard PLC, HMI, SCADA applications, control panels deployed across a facility, right? It's a specific vendor that is an approved vendor for the client, whether it's a Rockwell, Emerson, Siemens system, and it's oftentimes going to have a compatible HMI and historian for that entire solution. And once you decide to go with that, you're kind of locked into it, right? And this whole new software-defined automation is a paradigm shift from that.
I would agree with that statement. The foundation for, and we'll go over universalautomation.org in a bit more detail, but the foundation for the underlying framework is the 61499 standard. Now, everybody in this call, I'm sure, is very familiar with the IEC 61131 standard. The 61499 has been out for 20 years now, but has failed to find traction. And I'm of the opinion that that's because over the past 20 years, we've seen international standards and we've seen growth and cost effectiveness of industrial PCs go down. I really see a lot changing that is now getting us to the point where we can take this to market and prove that it's validated in a better way of doing things than we have in the past. So 61499 is really the IEC standard for DCS. We've been using 61131, and to my understanding, most of the DCS systems that are out there on the market are really 61131 tools. 61499 was the standard for IT-centric DCS interoperable systems. The challenge that we've seen is the business models of the automation vendors are such that they still want their customers to be vendor locked. They still want them to be a such and such customer. And, the fundamental challenge with that is, as an end user that, shops for a computer, I can buy best in class hardware for my needs, and I can do it from several different manufacturers and know that they all just work together seamlessly. This is the challenge and the realization that we're trying to make happen within the automation world, and I've seen great success in doing so.
Yeah, so I think talking about this as a influencing industrial automation in the future, what are some of the IT concepts like cloud computing and orchestration that start building this framework?
Well, we've taken a lot of the methodologies and IT ways of doing things for some very complex models. Like you said, cloud computing, AI models, networks. We've taken the ways of handling very big data sets and complex systems and applied the methodologies utilized in the IT world at the OT layer, predominantly things like object-oriented programming, which is existent, but not to this effect in traditional products. Things like interoperability of the software, again, across many different hardware platforms without any additional reconfiguration. The goal there is to break the vendor locked system, to make your software itself an asset that doesn't expire with the underlying hardware, that doesn't require additional reconfiguration or rework to go to the next generation of controller, or to go to a different manufacturer altogether, which is a complete, a complete rewrite of the code more often than not.
Yeah, I think if I'm as a system integrator and obviously as an end user, if I'm thinking about the prospect of, I can go with a different vendor for, my entire control system and not have to worry about hardware constraints or supply chain constraints for hardware. That's truly a game changer. What do you see as some of the things that have prevented that from really sticking on, like catching on so far? Like what's causing 61499 implementation across, I mean, aside from the desire to hold on to market share as a result of the current paradigm that we're in? Like, do you see anything else that's preventing this adoption from really kind of multiplying?
I do. And we'll talk about a lot of the technologies and international organizations that have enabled technology that will allow this solution to come to market. But, as far as resistance to a solution like this, from my experience, it's a lot of human issues. It's a lot of used to doing things the way that we always have. I saw a good reference case, and it was an immediate parallel to me. A couple weeks ago, we were looking at the California wildfires. I saw a video come out. It said, why do Americans use wood so prevalently in their housing, as opposed to our European counterparts that use more fire retardant materials? And it really came down to the foundation of how America was made and built. We expanded west so rapidly, and there was a prolific amount of wood, so that became our building material of choice. Now, there's a concept, and it's basically social momentum around a technology or decision, that once you start doing this, then Americans have this idea of what an ideal home looks like. It's this nice wooden thing. We've seen it. We want it. It's just the standard way of doing things. And as you move forward with an approach, industries are built around processing wood. Distribution chains, supply networks are built to enable that technology and way of doing things. Now, the interesting point that I saw in this video was, they looked at the fire in San Francisco in the early 1900s, and I think this was a wake-up call for a lot of people, a lot of building designers, that, this is the first time we've questioned, is wood really the best material? And they rebuilt it again with cement, with fire retardant materials, but it took a lesson like that to really question the way we've been doing things. I think there's a lot of parallel here with this solution. that we're so used to doing things, that there's industries built around supporting it, that it's well known and understood. But I do question whether it is really the best way of doing things. And I wonder, what is our fire going to be? I was system integrator during the COVID era. I was very, I struggled immensely with supply chain issues. And honestly, I don't want to get political, but I could see potentially with some of the tariffs, especially on semiconductor materials from overseas, I could see another supply chain issue happening in our near future. And this was a way for us to break some of the challenges that were forced upon us. Specifically, there are plenty of projects where I could not get materials, and we had to look at the liquidated damages associated with not delivering on time and do a cost analysis on whether it would make sense to redevelop the program on another platform or to pay the liquidated damages. Now, the engineering effort between rewriting that code, that same application, that same value-added portion, was so immense that oftentimes the liquidated damages won. So that's the challenge that I think system integrators are faced with, this inability to pivot, to work on developing a code. But then once they've built that, they're really kind of locked in to that code, that solution, those products, those communication protocols, whatever that vendor offers. Their hands are essentially tied in the sense that they can't pivot rapidly. And I think that, the supply chain is stabled a bit. I still see long lead times on engineering or on electrical gear, but quite honestly, I don't think that we're out of the weeds here, that a supply chain issue is potentially looming again. And I don't want to be the bearer of the harbinger here, but I can see that happening. And I think that this is a way that we are not going to be blindsided by something like that happening, because now we have a framework where if you're not able to get this material, you can consider other pieces of hardware with, again, the same value added portion of the code that you've already developed. No additional engineering effort. Now it's, if we can't get this hardware, let's pivot to somebody else. The application is still the same. So, the idea behind software defined automation is that the application is completely built on a workstation. It's completely software driven. You can test it. It's all virtualized. It's all proven. It's all validated before you ever connect it to any underlying hardware. That's really the power in this.
Yeah, and just to add on to that, from putting on my end user kind of shoes here, the whole change management perspective and having to get the culture shift and adoption to occur across multiple stakeholders to move into a different system, like that to me has been one of the barriers, especially having gone through a vendor change for a DCS implementation myself. It's getting everyone to buy into that mentality of this is going to be better for us for XYZ reason, and hey, now we're all signed up to do the documentation, to do to manage the change and implement the system. So I think that's another critical factor. But one thing that I'm wondering about is, we're talking about universal automation. We're talking about IEC 61499. Who are the members in that are really driving this? That's, that puts some of the credibility behind the movement.
That's a good question. Let me share my screen. I've got some content, and Ben, I'm actually going to take a step back.
Sure.
I'd like to go into OPAF first, and how the OPAF movement really was what launched universalautomation.org. And the majority of those members are still part of universalautomation.org. But let me share my screen quickly, because I don't think I'll be able to do it justice just listing off all of the members and growth that we've seen. So OPAF was around 2016. The end result, of course, was the OPAS standards, the standards of standards, because they didn't create any new technology. They just, in an international member-driven organization, verified the
interrupt
safety.
you just 1 second there?
Sure.
I don't think it's I don't have a share up yet.
Oh, no worries.
There you go.
Nothing terribly worth sharing at this point, but OPAF.
There we go.
Was,
Okay.
again, the organization where these vendors got together and said, we need a better way of being interoperable. We need a universal way of doing things. We need to match the success that we've seen in the IT world. When I when I open up my computer, I always say this, but it's valid. When I open up my computer, I'm giving this presentation on a Lenovo, right? But to me, as an end user, I don't care if it's a Lenovo or a Dell or a Toshiba. When I open it up, I have the same user experience. I have no issue sharing my information between other different manufacturers, and it just works seamlessly. This is the idea that we're trying to replicate within the controls world. But this is what end users have been asking for, and OPAF was the first consorted effort, I guess the biggest consorted effort to make that happen. End result of OPAS was ultimately a validation of 61499 as the preferred way of doing things. And again, OPCUA, an emerging communication protocol that is vastly superior to non-tag based systems, that is again widely accepted across many different manufacturers, as it is a gold standard really for communication. And based on the success of this, ExxonMobil put together a massive test bed. So Schneider's been working on their 61499 tool for about 20 years now. And again, after the OPAF movement, it was time to test out the technology that we've been putting together and working on for so long. And again, based on the success and the collaboration that occurred during OPAF, same members got together and created a massive test bed. Now, ExxonMobil, life safety, of course, they have a policy internally that they have to validate any new technology for a minimum of 3 years in a virtual environment before it ever gets even considered to be deployed in the field. So at the end of the OPAF movement, this was the test rack created. Again, all of this running Schneider's 61499 hardware. Now, what's interesting to me about this is there's not a single piece of Schneider hardware anywhere on this rack. There's many different vendors, but they tested and proven the system that you can be interoperable and work with many different manufacturers on this one common framework, which is the 61499 runtime. In fact, this was so successful, and other than a few Raspberry Pis blowing up, not exploding, but dying, blue smoke, it was pretty seamless. The brilliant engineers that were involved with this got a little bored and eventually moved all of the control off of the physical devices. And you can't see it, but there's a server rack in this area right here, where they moved all of the control onto a safe, clean, redundant server rack. Again, just using Ethernet IO drops for the simulated field portion. But this was wildly successful. So at the end of this test bed, at the end of the 3-year test period, universalautomation.org was launched. What happened here is Schneider gave away the physical runtime portion of this. The engineering portion we call Automation Expert. This is our IDE. This is our design and engineering tool, our build time tool. But the 61499 runtime element is now given to universalautomation.org. So think of this as a GitHub type management system of this common shared runtime that again ensures no one vendor can really own or manipulate this common framework. So at this point, Schneider is just one member among many that works on this common framework. Now we can update our engineering tool, add features, functions, but the actual runtime element, we just have one vote, just like everybody else, to drive the growth and progression of how that evolves. That is generally the idea behind universalautomation.org. They're nonprofit. It's an international organization. Lot of members. Again, this is not a current list, but it's pretty up to date. And really what I'm seeing with universalautomation.org is we're seeing the most growth from end users. People are tired of challenging systems where it's hard to get information from the OT level to the IT level, where they feel vendor locked and stuck in certain systems. It's the end users that are crying out for this, that want something that is open and interoperable.
This is interesting to me to see, like when you showed the OPAF members, and there's, I think Microsoft was on there before, but now you're starting to see like Intel and other chip manufacturers, and the idea of moving this onto an industrial PC or onto a server system, or even just onto edge devices away from a dedicated controller is pretty interesting. And I think it's worth maybe going into some kind of discussion about the build time that you guys have developed for this, because I think that's really one of the exciting things that we have to talk about today. Um, and I think the first question that I have as a system integrator is, okay, there's the automation expert build time that Schneider has built. Who is anyone else developing build times that you're aware of right now?
Absolutely. There's an open source 614.99 platform. It's 4DAC, more of a proof of concept than anything, not a functional control system that's been deployed in the field anywhere. But the fundamental idea behind universalautomation.org is there can be multiple design environments with different features and functionalities and ways of doing things. But if you build it on a universal automation IDE, it's going to run on all the universal automation hardware that is certified by this common runtime, as well as any Linux or Windows-based device. And that's really the power that we're seeing with software-defined automation, is utilizing industrial PCs of virtualizing controllers. Now, I've talked to a lot of people over the past couple of years. Talked to some very senior engineers that have been around since the 90s that were there when 61131 was being formulated. And they felt like they got burned because the way it was originally presented, especially those that were working on the formulative stages, was that now we're getting a common language so that we don't have this vendor-locked lack of interoperability challenge. I've also seen Windows-based control fail in the past, and for good reason. Windows, it would never deploy in an operational setting. There's just too many background processes. There's needs to refresh. It's not really suitable for a Windows environment. Now, I'm curious, Ben, have you seen software-defined automation in the past? Have you seen an attempt at using virtualized control in your experience, and how did that look?
um, Nothing actually in my official automation career. Back as a microbiologist for a company that I worked for a number of years ago, yeah, we actually did do some control with a Windows-based system, and it was all kind of it was prototype development for a cell culture reactor. And so it was all things that we could get, our hands on without having to go into a specific control system. So we ran into lots of issues with trying to get the data off of it. It was, in text files, and of course the security issues of making sure a desktop PC in the lab was locked down and people weren't trying to get onto it to stream music, and that sort of thing was a big problem, which, fortunately nowadays, there's a lot more knowledge around cybersecurity requirements, especially in the larger companies. But, as a small startup company, for us, it was inexpensive. Um, but it was also uh, a lot of manual labor that had to go on to move things around and connect things in, and find interfaces that were able to control the stepper motors that we were controlling, or the photodiode array detectors that we were using to collect data. So
Yeah.
it was problematic, and that was, I think, one of the things that we saw that a lot of people see is, like, PCs were not a reliable source for control 20 years ago.
No, no, and we've seen incredible growth in cost effectiveness of industrial PCs, especially over the past 20 years. Last 10 years, I've seen it take off and be just as cost effective and competitive, as a PLC. Same robustness, steady state drives, fanless. You can throw it against the wall. It's epoxy resonated, and it'll work. And it'll have the same life cycle as a PLC because it's so hardened. It's got the same temperature ratings as a PLC, but what a PLC doesn't have is the computational ability that an IPC has. You look at the top of the line Schneider or Allen Bradley processor. You're looking at 64 megabytes or 40 megabytes roughly of system memory. Whereas if we're looking at an industrial PC, I mean, we're in the range of gigabytes, and that's really the power of software-defined automation. It's the ability to introduce computational power at the control layer, so that now you can run your control on this IPC, have an incredible amount of computational ability still being unused, and introduce edge applications, things like predictive maintenance, or AI. Again, all behind the firewall, all locally controlled data sets. But that's really the power of introducing IPCs into the control field. It's the advanced computational ability that is really allowed to exist.
Can you talk a little bit about like redundancy and failover? Because I think that's always a concern with IPCs too.
That's actually one of the more interesting topics. I'm glad that you brought that up. So being a software-defined automation, again, it's a network of smart interconnected devices. It's not one device communicating with another. It's a system level. And honestly, within the platform, a lot of the cross communications are automatically connected. You say, this is the device, this is the communication protocol, this is where it's going, does the Modbus mapping for you, does OPC UA for you, does whatever communication protocol you're using. But what's interesting about, it seems like a risk, but it really isn't. As you add computational resources at a system level where you can remap applications in real time or portions of applications in real time, there's this idea of a cold failover that since it is a system level device, if you have, let's say, our M580 flagship controller running over here with an IO drop and the controller goes out, if you're using a 614.99 solution that's software defined, you can in real time remap the portion of the application that's running on that controller to some other area in the plant that has the computational ability to support and run it. You have an IPC with a couple cores that are not being utilized. You say, let's move this so that we can continue operation until we can replace that controller. Effectively turns that controller rack into an Ethernet IO drop, and you're up and running as soon as an operator can respond. I'll take it a step further, actually. We did a collaboration with Intel and Red Hat where we use their software to create bumpless failover if you lose an asset. And of course, it's demonstrated. You can unplug a cable and take the power off. It'll instantly look at all of the computational resources of the other devices within the system and then automatically remap it to a section where they can handle that. So we have high availability in a way that really hasn't been considered or chewed over in the past, where we just have two controllers running the same program with instant failover. This is an ability to rewrap resources across all of your various connected devices and do it, either manually intervene with a cold failover, or you can introduce software that automatically remaps a failed controller's portion to another portion of the system that can support it.
Yeah, you're talking about Red Hat's Ansible software right there. Because I think that's a phenomenal idea to be able to take an image of an entire network. It's actually a shameless plug that my excuse me, my brother is the IT/OT SME for Avid in one of our Ansible wizards, and we kind of nerd out all the time about the capability to automatically deploy software solutions given an image. And if you can do that for your control system to automate kind of this whole failover process, I think that's a step change in technology that's compelling.
I agree. I think the audience is tired of seeing this screen, so I'm gonna progress really quickly in universal automation, then I'll shut it down so we can keep talking. This organization started in 2021. It's a relatively new organization, and I mean late 2021. It originally started with 9 members. It's grown at an exponential rate. The curve here is not reflective. I just kind of changed this total, but we are seeing just phenomenal growth in this. It is typically end user driven, but we're seeing more vendor offerings. Just last week, Honeywell, and again, this is huge for me. I celebrate it. Honeywell joined universalautomation.org. Again, I know they're going to put out hardware that can support this. And the more products we have that support this open and interoperable system, the more power the end users have to be flexible in how they conduct things, how they create their system architectures. This is really the power that this universal solution allows. So I'll stop.
Yeah, I think that's really interesting there, that end user driving that comment. So you see someone like ExxonMobil who has a large Honeywell install base, right?
Yes.
I think Exxon has a lot of clout behind this that's helping drive it. And one of the life sciences companies that I noticed on there is Novo Nordisk, and obviously they're having a lot of success right now with their production of their products in the United States and globally too. So
Well,
It'd be interesting to see how companies like that continue to drive the change towards 61499.
I wasn't going to mention it, but you said it. I mean, yes, ExxonMobil is, I think, the biggest Honeywell user in the world. And again, was frustrated with the migration costs constantly needed every time they modernize the system. Cost of downtime is immense in those types of environments. And the reason I make this point is I often get the question, where's Alan Bradley? Where's Siemens in universalautomation.org? And my response has always been, this goes directly against their traditional business model. This is a solution that really contradicts the vendor locked and proprietary way of doing things. I think that they will eventually join. I see it as inevitable. I believe they're going to build their own engineering tools, but they'll offer hardware that is not part of this universal system. But it's going to be because end users see a better solution and way of doing things. And this is why I mentioned Honeywell. I think they are catching up to the potential of lost business with such a giant like ExxonMobil that they're joining universal automation, perhaps kicking and screaming, but they're joining. And this is inevitably what the end users are asking for and wanting.
Yeah, I think so. That's interesting. And as we talk about the end users driving this, like there's other potential users out there that might be struggling with how to migrate their system. And you and I have talked in the past about ways to do that in phased approaches, but I was wondering if you wanted to kind of prime that part of the conversation and talk about how to get started in this.
Oh, you mean my shower thought yesterday that we were talking about? Yeah, absolutely. I was thinking about how I would approach this tool as a system integrator, how I would use it to potentially drive business where it'd be a challenge to find some in the past. And I think the beauty of this is that you create a phased approach. That if you have a customer that needs to migrate but doesn't have the budget or is unwilling until there's a catastrophic event, then you can potentially, as a system integrator, sell the conversion to a universal platform. And because you can, again, it's a complete tool. It's HMI, it's historization, it's documentation, it's visualization, it's OPC UA server client across the board. This is a tool that is meant to unify all these disparate softwares, alarm management, all of this tied into one design environment. But that's really what I think is powerful, because once you have a converted application, that's typically the time consuming portion. And as a system integrator, we hate being overtime pay. All right, guys, you're working, it's overtime, but we're going to work you to the bone because this customer is down and they have the budget now because it's catastrophic, but you're having to do that engineering work under the gun. And that's just not the best way of doing things. If you can pre-convert your application and then continue to run your hardware with the knowledge that you have a pre-validated converted application that is now future-proof, then you can use it as a staged approach. You can convert the program to this universal automation code. And then when it does fail, or when they do have a budget cycle where they can actually replace the hardware, that's stage 2, where you physically deploy it, but it's already tested, validated. You can simulate process conditions within it. So you can test your alarms, your interlocks, your permissives, your HMI, OT interactions. You can test all of your cross communications of devices using virtual PLCs. So when the time does come, or when the budget cycle does come, then your application, which is again about half of the project from my experience with modernization efforts, is already done and accounted for. So it adds flexibility as to how we can approach some of these projects, and it's not an all or nothing thing. Gives the customer peace of mind as well, knowing that, hey, we may get another 10 years out of this old PLC 5. Those things are robust and impossible to find parts now. I mean, eBay and Prey in this world, but maybe it's a food and beverage operation with low margins, and they want to get as much life out of that as they can. Now they have the peace of mind knowing that the conversion of the program has already occurred. And when it does fail, then they can look at the market and say, all right, what products are out there? Because the products of today are not necessarily what they're going to want to shop from if new and improved products are out 10 years from now when it does actually fail. So a novel approach, I think, but an interesting.
It begs the next question, though. Okay, so Avid traditionally has been supporting Rockwell installations, and a lot of our clients use Rockwell. what kind of effort do we have to go through to train our engineers to become adept in something like automation expert? Whenever I talk to our engineers, they're like, oh, we understand this. Give me a little bit of time to click around through the interface, and I'll ask some questions to the SMEs after that, and then we'll be good to go. But you want to be able to sell that expertise as a system integrator, knowing that there is a certain level of training that's been accomplished, and there's a backing from the manufacturer, the vendor, to be able to uh, fill the gaps when that arises.
I will definitely say there is a bit of a learning curve, because this is a tool that looks and feels more like our software IT design environments, that appeals to younger engineers because they've had the ability to play around with IDEs in the IT space, but rarely have the opportunity, unless they're in a specialized program, to really get into the ladder logic and factory talk and Modicon-based tools that we're used to using. It is a learning curve because it's a different way of doing things. 61499 is event driven, where 61131 is cyclical. Completely different way about thinking of things, but again, event driven is what's necessary for it to really be TSN sensitive and able to interact with IT systems in an easily usable way. Schneider, of course, does have a fixed training path. It's actually not that extensive. It's similar to what you would see with your 61131 tools. But it's a very user-friendly tool once you understand the functionality. And because of this idea of object-oriented programming, you can have a senior engineer that really knows the inner workings of it, create these function blocks, these objects, and create the library, and then have some of the younger engineers do some drag and drop, do the network configuration, go through the virtualization, go through the testing. But you can have one person that's really focused on the code and the technical details, and then everything else is just an object, and you're just connecting lines, drag and drop, plug and produce, single line engineering. I mean, this is the way things are done in the IT world.
Yeah, you've mentioned IT stuff a few times, and IT-driven solutions obviously come with a concern of cybersecurity. How do you guys address that?
That's a great question, and I'd say we address it in a way that is not traditionally accomplished in the control world. We're used to addressing that with our network architecture. Our firewalls, our gateways are very, very specific flow of information. And I'm not advocating that we change that at all. But because this does use IT technology, there's additional encryption at the control layer without affecting your network architecture at all. Specifically, TLS encryption is what we use to protect all of our financial data, all of our government data. I mean, this is the encryption tool that is utilized predominantly in the IT world. So you're adding an additional layer of encryption to the control layer without, again, ever addressing the network architecture. Keep your gateways, keep your firewalls, control everything very specifically. But because of that, it's a 62443.3 certified cybersecurity platform. I don't think that many can make that claim, at least not at a system of devices level. So I would say that it adds robustness without really affecting the way that we've done things, so that if you do have a bad actor that happens to penetrate the network, disgruntled employee or something, all of the information is encrypted point to point. You can't read information, you can't send commands. It is all completely unusable unless you are working on the design environment and physically deploying it.
Yeah, I think one of the other interesting ideas of the software-defined automation that we were talking about before is the idea of, using Ethernet cable rather than twisted pair, and running hundreds or thousands of twisted pairs throughout a facility, and basically having the control live at the device rather than the centralized control panel or the Rio panel or whatever. Let's talk a little bit about that idea of like having control exist on a VFD, and some of the other kind of emerging technologies like machine vision and stuff like that could make a good use case for automation expert.
I think you make some very interesting points here. We've seen the rise in acceptance of industrial Ethernet. And as we really see more devices, more smart devices come out with computational resources, with smart Ethernet connections, we're seeing less and less physical hardwired I/O. Now, run with me on this conceptual idea here. If you have a PLC and you're only connected to smart devices, there's no physical hardwired I/O. Everything is just RJ45 ports coming back. What really is that PLC at that point?
Yeah, that's a computer.
I mean, it's
a switch, right?
It's a switch with a little bit of computational power.
Yep.
And it's that realization that, I think the IT companies have come to accept. And this is why this change is not coming from the automation people. It's coming from the IT people that want to get in. It's coming from Intel. It's coming from Microsoft. These are the people that are trying to get a piece of the automation market. And so if we fight this, then we're really just fighting what I consider to be an inevitable change in technology.
Yeah. Nathan, we're about 15 minutes away from the end here. So I don't know if you wanted to jump into anything, because I think, whenever I'm in discussion like this and we're talking about a tool, I'm like, well, show me the tool. I don't know if that's something that you want to do, I think, we're in this kind of realm where all tools kind of look the same. It's got a navigation bar on the left. It's got some, menu bars at the top, and it's got a workspace in the middle. So I think, from what I've seen, it fits that format. So it feels very comfortable to get in and work from. I think it's, before we get to opening up for some questions, if anyone has any kind of topics that they want us to delve into a little bit more here, I feel like it's probably good to just open up the hood a little bit.
Yeah, I mean, I know we're with system integrators, and if they're like I am, which most of them are, is let me play around with it. Let me see it. I mean, this all sounds nice, but show me what it looks like. I'm not going to go into too much detail. I'm not going to go into the weeds too much here, but this is the basic layout and configuration and functionality of Unit of Automation Expert. So very clean code. Everything is asset centric, asset oriented. Again, it's usable, intuitive, and object-oriented programming. There's this idea of encapsulation where you can take sections of a plant, and then within that section, they have all these assets. And again, if there's multiple sections of the plant, then you can copy and paste that with all of those properties, with all of those underlying objects, again, associated with the next instance. So here we have our stockpile feeder. It's a fairly simple application. We're looking at a hopper feeding a ball mill. But the power of this is that it's really a system of tools. It's a true DCS way of doing things. You can simulate the environment. And it'll start the process condition, and then you can test your alarms, interlocks. And again, one of the more interesting things that you can do is introduce some of these AI technologies. So on this ball mill, of course, is very high availability. It's got to be critical, mission critical motor. We've got a Edge IO or a Edge AI predictive maintenance protocol deployed on one of the IPCs running and controlling that ball mill, where we are monitoring the motor itself and getting predictive feedback on the areas and concerns to, again, prevent failure and then plan for a downtime repair if needed. But it's introducing these tools at the control layer without cloud connectivity that really is the power of this. There's a lot of end users that we see that simply hard stop when you hear cloud connectivity. Mining sites, government agencies, military bases, cloud is just a no-go. So if you want to do some of these AI-based cloud tools, you need to have a physical deployment where that data set is running without the need to connect to the internet. And that's really the power here. And then, of course, the alarms generated from this tie into the general alarm screen. That a failure can then shut down downstream equipment, again, as a system of systems, and to prevent impending failure to downstream equipment, or the need to additionally clean up product off a belt before you start the line back up. So this is generally what it looks like. You can drive into any of these objects. And see that it is, again, a system of objects. So initialization when it starts, what values you initially have populated, your HMI section up here, again, all very visually intuitive. You can drill down to anything, but it's very easy to manage the code. No more spaghetti code, no more pages on pages where you're having to reference back and forth. Everything ties. You can see where every data piece connects. This is the idea behind single line engineering. And these lines are bidirectional communication too. This is not a sequential operation. Because it's event driven, these lines dictate that there's information flowing between these devices and it can go both ways.
So where do you see this going in the next 5 years?
Schneider has continued to add features, functionalities, to update the version. We're on 24.0 right now, with 24.1 coming out shortly. We're really prioritizing the needs of our end users to address the roadmap on features and functionalities. I've seen projects where this key technology was not part of the platform, but this was the only thing that was stopping somebody from moving forward, and then this would solve all of their problems except for this one issue. I've seen them redevelop the roadmap to address that specific issue. So it is a feedback loop in this sense, but they're going to continue to add features, functionalities, roll out new versions, with a big focus on reverse compatibility, on version control. In fact, we should be launching a cloud-based tool that manages version control between all of the different automation expert platforms, I believe, as well as the Modicon M580 and 262 platforms as well, the machine expert and control expert.
So I think for anyone who wants to explore this further, what do you think their next steps should be?
Well, I would love to dive into this in more detail. Ben, you and I could talk for hours, that you could plan an entire semester curriculum around this content. So this is as high level as can be, and I'm looking at the list of notes that we put together. We covered about half of it, right? It's very easy to dive into, and that's completely fine. So, I'm more than happy to go into a deep dive. More than happy to set up a meeting, go through a demonstration, talk about real life use cases. I'm here and I'm the person to help accommodate that. Just reach out to me. I'll put up a slide now for our contact information, or if they want some third-party experience from you, then they can follow up with you. Or if they're skeptical about Schneider's way of doing things, then I would encourage them to go to universalautomation.org. Go to the actual nonprofit, go to the open organization, start there, and really validate the technology from there and decide whether it makes sense to consider the engineering tool that Schneider has put out there, which is best in class.
Yeah, and from the system integrator perspective, there's the alliance partnership that Avid has become an alliance partner, and that enables access to training and subject matter experts to help get the engineers kind of up to speed on being able to deploy these projects. So that's something that we are engaged in right now, and honestly, it's been a very nurturing partnership that that we very much have appreciated so far. So look at those wonderful pictures. So there we get some contact information for Nathan and I, and we're happy to field some questions about this, and thank everyone for attending and listening to our little back and forth here on what Nathan and I are pretty excited about. Hoping that the 61499 standard penetrates further across industries so that we can nerd out more about it.
And real quick point before we jump into questions, this is a new technology. Schneider is validating and is unwilling to put out any bad deployments. There is an immense amount of co-engineering, of a partnership approach to developing applications, where we personally have a very, very detailed vetting process before we say, okay, this is a go or no go for universal automation. We look at all the technical details. And then once we say it's a go, you're going to have incredible support. You're going to be working with myself. You're going to be working with Osama, one of our SAEs, to really develop the application and come up with this core concept, this proof of concept. But it is very much a partnership and a co-engineering effort. And this isn't something we're going to send you to training and say good luck. No, this is going to be a very hands-on collaborative effort with any of the projects deployed until, again, the system integrator is incredibly comfortable with the tool. It's the nature of things. So for the sake of time, I'm going to shut up. I can't see the chat. Let me pull that up. Are there any questions? Do the guests have ability to access a microphone, or do I need to pull up the chat?
So we go ahead, Osama. We do have some questions in the Q&A feature, and anybody else wants to pop them in there, feel free. I believe your colleague Osama is going to lob you the questions. So I'm going to shut up now. Bye.
Osama, any
No, I
questions?
greatly appreciate that. So yeah, so one question that comes up, is there a trial version that someone can use to test this cool stuff and check his features?
Absolutely. I mean, absolutely. I'm more than happy to provide a trial license. You can play around with it. I'm the exact same way I have to. But because it is a new tool, we would really encourage a bit of training. It doesn't need to be formalized paid training. We can come out there, we can do a workshop, go through a 1-day effort where we really go through the nuts and bolts, how it all works, to get you up to speed and familiar on it. Because we don't want to discourage anybody with the design environment that's not familiar or relatable to something they're used to working with. But yes, absolutely can help set somebody up with a trial license. I think it's a very American necessary way of doing things, to just physically touch it. And again, we hear a lot of sales talk, so it's good to
That leads to another question by Rafi, and he's asking, what kind of licensing offers do you have? Are they subscription, perpetual? And what kind of materials for educational purposes are available for free?
Currently perpetual, and don't know if that's ever going to change, but it's currently perpetual license. The cost of that is very competitive with your classic 61131 tools. Of course, with additional functionality, I'm just talking about control expert versus universal automation. Not even factoring in HMI software, alarm management software, historization, all of these things that are typically separate packages, OPC servers, all containerized within universal automation or automation expert. I use them synonymously. But it's very competitive. The way that it's licensed, it's the number of physical devices. So you can start at a very skid level, very small application, be cost effective, and you can scale up, again, because it's on the number of assets that you're controlling, to be very competitive with a DCS solution. And when I say very competitive, I mean, we blow pricing out of the water with greenfield DCS applications. So it really is scalable. You don't have to have a full-fledged system of systems to go into this. In fact, that's really the approach that I like to push people to take, is introduce this at a certain point where you need to modernize, and then just grow from there. Use this as a tool to interconnect the other devices, and to orchestrate is a term we use often. But really, you can introduce this today and then grow it from there, while adding incredible functions and features that you just couldn't do with the traditional control system.
And that brings another fun question but I guess both of you could probably chime in on this one easily. And they're asking, Zachary's asking, given the shift of the traditional PLC programming to more integrated network style systems, what kind of engineers do you foresee becoming more valuable for programming IPCs? Is there like a specific software, specific system, rather than a standard PLC programmer?
We're all
Man,
unicorns, right?
go, yeah.
No, just throwing that joke out there. We're all unicorns anyways. And there's we typically have the mentality that it starts with being a controls engineer first and foremost. Of course, the chemical engineering background is very important to being able to understand the process, and then you can teach somebody all of the kind of IT side of things very quickly, much more quickly, in our opinion, than you can teach the chemical engineering background. That being said, we do at Avid mostly have chemical, mechanical, electrical, and computer engineers on our staff. So I think those are kind of the four probably that I would say are the core engineering backgrounds, educations to be able to go into system integration in general. But to take on this kind of programming, I don't see much difference from traditional controls engineering. Nathan, do you agree with that?
Entirely. In fact, I agree that you're going to see more process engineers, because we're looking at a program not based on the physical control hardware that's running it, but we're looking at it at an asset level. You work more with process engineers. You work more with software engineers. In fact, this is a tool that really helps bridge the gap between the IT and the OT world. where in my experience, these two entities do everything they can to stay away from each other, to never communicate, to never talk. But we've been hearing about a decade now for IT/OT convergence, and there's a big disconnect there. And in my opinion, is that we just haven't had the right tools or framework to create an environment where both people could work on a system, have their own specialization and understanding, and come together to collectively really get that IT/OT convergence layer addressed and talked about.
Guys, I'm cutting you off. If anybody wants to talk to Ben and Nathan about this further, the little cute little QR codes are there for you. But otherwise, thanks guys. And on behalf of CSIA, I would like to thank Ben and Nathan and Osama for this informative discussion. And also thanks to Schneider Electric for sponsoring the event. And of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thanks for joining us and have a great day.
Thank you,
Thanks,
Lisa,
everyone.
and everyone.